Okay, hello everyone, and welcome to the most exciting moment of the week, to the most fantastic module, and this is Energy, Technology, and Society. So, today I have the pleasure to deliver this very interesting lecture that is related to bioenergy. And bioenergy require a very good understanding about chemical processes related to the organic matter. So, without further delay, let me jump into this lecture. So, let me start with the lecture outline. So as you can see over here, I will start with a very important introduction related to the biomass conversion technology. Then I will examine the status of the biomass around the world and consider some possible conditions for the deployment of the biomass. Then we will talk about the barriers and opportunity for the biomass, and finally, we will close considering sustainability issues related with this type of energy technology. So, now what I will show you here is the learning outcomes. So, as you can see, I have a list here of 5 bullet points. You will appreciate the range of biomass conversion technologies, be aware of the current status of biomass worldwide. We will be able to consider future prospect of biomass, also appreciate barriers and biomass energy deployment, and finally you will be able to reflect, argue, and consider ways to reduce those barriers. So, a very important aspect is that we establish a definition for biomass. So let's start with this formal definition. This definition is taken from a book from 2002. Of course, it's a relative old book. You can find this book at the reference list. However, what is important is that the concept is still totally useful, and what you need to understand is that this is a recent organic matter. So we are talking about organic that was originally derived from plants or also animals as a result of energy conversion processes, for instance, in the plant using the photosynthetic conversion process, or also chemical energy that is stored inside the animal matters. So, 2 important aspects over here. We can obtain biomass from plants, we can obtain biomass from animals. In both cases, there is a chemical reaction that will allow you to get or to regain access again to this kind of energy, okay? So now what we will do is we will discuss about energy from biomass, fuels, and energy uses. So this diagram over here is extremely useful because allow you to understand the different ways that we can obtain the energy from the biomass, fuels, and the end users. So let's start the explanation of this very interesting diagram, but looking here at the top. So at the top of this diagram, you can see over here the principal fuels, and you can see that we can obtain the fuel from wood, from crops, forest, and many other elements coming from the plants, but also from animal waste and biodegradable wastes. And in those cases, we have different type of conversion processes in order to create intermediary products end-use technologies, and the end product. For instance, one of the most used application of biomass is using wood to get energy. So there are three basic processes that we will be discussing later in this class today. We have combustion, we have pyrolysis, we have gasification. When we have combustion, of course, we can use, for instance, the stove or the boiler, and the final product that we will get is basically heat. However, there is another process that, for instance, we can take from here again the wood and applying something that is called pyrolysis, and from there we can obtain some sort of biofuels like bio oils or fuel gas, and those fuels can be used in different stages. For instance, they can be used in a classical steam boiler or combined heat and power plant, and from there we can obtain directly heat, or we can obtain, using the process that we already described in classes, obtain electricity. So in another way, we can use the wood as fuel, use gasification, that means transforming the solid material, the wood, into a gas, and that gas can be used for a classical gas turbine to produce electricity. So from here, you can see that we can use wood, we can use, for instance, some waste or cheap pellets in order to produce heat or electricity. However, as you can see, there is another part over here. This is related with animals, and we can take those animal waste in order to use a process, a chemical process, anaerobic digestion, in order to create a gas, and this is methane. And this gas has some calorific power that can be used for a gas turbine, and from there we can obtain electricity. So the last part of this diagram over here, you can see that we have high energy sugar and some other starch crops, and those crops can be fermented in order to obtain some biofuels like methanol or ethanol, and from there they can be used in some internal combustion engines like the classical spark ignition engine in order to provide motive power for transportation. So, for instance, in some countries like South America and Brazil, you can find these kind of methanol and ethanol that they can be used for a very specific cars or public transportation. On the other hand, there are some high energy oil crops, animal fats, algae, that they can be applied another conversion process that is called esterification. And from there, we obtain the biodiesel that again can be used into internal combustion engine. And from there, we can use for transportation, okay? Public transportation or even for your car. Finally, here you can see that we can use algae or bacteria in order to use a very interesting process that is called enzymatic, that is similar to some processes that happen by those chemical components in the body. And those enzymatic processes, what they are doing is using the properties of the bacteria, of the algae, to produce hydrogen. And this hydrogen, of course, can be used in several ways. We already recognize that. We can use that for fuel cells, for power plants, for engines. And at the end, we can use this hydrogen for many, many applications. Applications like power heat, motive power, and so on. So as you can see, this diagram over here that has been taken from a book that is called Power Plants Biofuel Made Simple. This very specific diagram is very useful because allow you to understand a general picture about what is happening with all the biomass, the energy coming from the biomass, fuel, and the end users. So now let me move forward a bit And now what we are planning to do is go to the next slide. And over here, you can see that we have different ways. And you can see on the first block over here is basically talking about the feedstock. So here, what I am talking about is basically the primary energy source that we are talking, for instance, oil crops or sugar, on some cellulosic biomass or biodegradable or some photosynthetic microorganism. So the idea is that those primary energy sources, we can use different techniques in order to get another form of electricity. For instance, we can use those oil crops and we can use combustion, and from there we can obtain the classical heat and power. Or for instance, we can use this cellulosic biomaterial, and from there we can use pyrolysis or gasification, and from there we can obtain several other things, like for instance liquid fuels or also gaseous fuel. In other words, what I am trying to tell you is that this diagram is probably another representative way to make the connection between the primary energy source and the conversion processes that they are used to produce a final energy like heat or electricity power, or creating another kind of fuels like liquid fuel or gas fuels, okay? So let me move forward here, and what I will show you now is that basically there are many biomass fuel considered for the electricity sector, and you must recognize that when we use this phrase over here, power generation, what we are talking about is the electricity. So talking about electricity, there are many ways to get electricity. Of course, many of them has advantages and disadvantages. Some of them have some considerations to take in account. Some of them are more efficient. Some of them can be used in a very large size, or in other cases in minimal size. So if we talk about biomass fuels, one of the most used biomass fuel is the wood. And in this case, we are talking about for the specific forestry wood, that is wood that is used specifically with the idea of producing power, producing energy. But there are possibility of agricultural residues, or grasses, or sugar cane, or energy crops. That is a tendency very recent, that is basically dedicated to to grow in some fields very specific crops that they can be used later to produce energy. So they are also vegetable oil, coffee grounds, green waste, and many other sources. Of course, depending on the sources, the conversion process can be very different. So here you can see that there are a very large spectrum, or a large variety of biomass resources. Of course, when we are considering power generation, we must clearly understand that there are some biomass resources that they can provide a very good potential for a continuous power generation source. So that is a very good advantage in order to cope with the challenges of the future related to the variability coming from other renewable resources like wind power, or of course photovoltaic systems. And another important feature of these biomass resources is that some of the traditional power stations, they are able to receive directly this kind of biomass resources. That is called also co-fire. So in those cases, we can take the advantages of the already installed and already working conventional power station, but in this case we will take the advantages of the biomass resources in order to make those traditional power plants, conventional power stations, more environmentally friendly. In some cases, especially in Nordic countries, it's quite popular that the biomass resource is used in combination with other energy production. So the name CHP must be no new for you, and that is dedicated for combined heat and power. So in some Scandinavian countries or Nordic countries, there is something that is called the council or district heating. So we use the process that is called CHP because we can use this biomass to produce heat. From there, we can extract heat for electricity production, but at the same time, some of this heat can be used to boil water, and that water can be used inside the community in order to create heating, for instance. So it's quite interesting also that the biomass resources can produce energy that can be recovered from this organic waste, and again that can be used for multiple uses. So another tendency is to process the biomass, and from the biomass we obtain some fuels. They are called biofuels, and those fuels can be used in order to be used in very specific transportation systems that could be public transportation, that they are able to use in a proper way all the heat that is produced by these biofuels. Interesting property of the biomass resources for electricity application is that they can grow as much as required. Of course, if we have enough resources like the land or the agriculture allow space to the growth of this biomass, and also if we have enough transportation and biodiversity to allow the biomass resources to grow. So this is a very interesting analysis. You need to consider in this case that biomass has enough potential to help in the energy transition, especially because this kind of energy allow more controllability on the generation, and that is able to cope with the variability of the classical renewable generation, but is also able to help with the flexibility that is required in the future energy system. So now let me move forward and let me talk about some of the very important conversion processes related to the use of the biomass. So if you go to the literature, there are many conversion processes that they can be used for producing energy coming from the original biomass. So here I will basically focus on thermochemical conversion, that is one of the most used, especially for electricity production. Then I will tell you about the microorganism and the enzymatic process that is used in very limited capacity, but there are some very important advantages of this. And for the last, I will talk about the chemical process that is called esterification, okay? So let's start this discussion. Talking about what we call the thermochemical conversion that is called gasification. So what does mean gasification? Gasification is the process where we have, for instance, a solid biomaterial, and this primary component, this primary mass, is converted fuel by the oxidation at very, very high temperature. So two important properties here are: first, we need to have fuel, and that fuel will be going into a process that is called oxidation, that is performed at very high temperature, and from there we obtain some gas that is combining or extracting the energy that is stored in the fuel. So this partial oxidation can be executed in air, oxygen, steam, or a mixture of those previous gases. What is important is that after we have this oxidation process, we will obtain some products. Some products like carbon dioxide, that of course is not quite good for the environment, or carbon monoxide, that they are not very helpful for the environment. But we can have hydrogen or methane that they can produce electricity in a very, very important way. And some other products can be water or nitrogen. What is interesting is that there are many processes, oxidation processes, in order to obtain those biogas, and one of them is called the synthetic fuel production, using this very well-known process that is the Fischer-Tropsch. Here we are not covering details because we are not chemical engineers. However, what is important for you to understand here is that this gasification process take part in a very specific installation, and in this very specific installation, one of the important elements is that we need a lot of energy, a lot of heat, in order to create this partial oxidation. So the fuel will create a gas with energy carrier that can be obtained in the form of methane or hydrogen or CO2 or CO. Of course, we don't like those ones because they are affecting the environment, but those ones are very useful if we are talking about electricity production. Gasification process is not one of the best or largest process of producing electricity. As you can see here, there are some large scale examples, but the power is around 10 megawatts. So that is one of the typical sizes for gasification power plants. There are some of them located in Austria and also in Germany. And over here, I will show you a plot that is comparing basically the amount of gas that we can obtain using different processes, like, for instance, you can see over here the pyrolysis process at the very end over here. You can see here pyrolysis over here, but also we have here several others, like, for instance, the fluid bed air blown or updraft air blown. But what is important for you to understand is that each one of those processes, they have different proportion of gases that you can obtain. Some of them, they are very rich in nitrogen. Some others produce a lot of carbon monoxide or CO. And some of them, they are able to produce methane that they can be directly used for the production of electricity. So let me move forward. And over here, what I will tell you is about another very important process to produce chemicals that can be used for producing electricity. So here, as you can see, there is something that is called the thermochemical conversion, that is called pyrolysis. And pyrolysis is basically a very slow process that is irreversible. That means that cannot be changed, and is basically based in a thermal degradation of the carbon-based material at very high temperature. We are talking about between 400 to 800 Celsius degree, in order to avoid the use of oxidizing agents. And in this very specific case, so we are not creating a gas, so we are obtaining some sort of combination like liquids and char that they can be obtained and used for producing electricity. So the typical process is shown here below. You can see that the biomass arrived to the plant. The first step is trying to take out all the water in that biomass, and that process is called drying. Then we apply some mechanical process in order to reduce the size, in order to make the thermal reaction to be more efficient, and that is grinding. And then we go inside the pyrolysis reactor, where all the chemical reaction happens, and at different stages you can have different of the products. The last one, but is probably not the most, the not desired, is a biogas, but here we can get the direct pyrolysis products, and you can see over here we have char and we have some bio oils. So again, the pyrolysis process is basically allowing you to create a new material where we are extracting all the energy capacity from the biomass and transforming that energy capacity into a liquid or a solid. So basically, there is temperature related or temperature conversion of the biomass. We are not allowing air to be involved, so that is the reason that there is no oxidation. And depending on the temperature that we apply and the speed of the reaction, we can have different type of subproducts. For high temperature, we can have gas, but also for relative or relative low temperature, we can have something like the charcoal, okay? Of course, those numbers are just an approximation depending of the nature of the biomass. Those numbers can be larger or smaller, but what is important is that gas, bio oil, or charcoal can be obtained as product of this pyrolysis. So in the next slide, I will show you a comparison about the percentage of the elements that can be obtained at a temperature of 500 Celsius degree when we are using different sources. For instance, biosolids, or we are using over here paper, or we are using, for instance, wood chips. And what is important is that we have the three subproducts over here. For instance, if we are having paper, you can see that probably more than 45% of the product will be oil. But for instance, if we use, for instance, biosolids, you can be that are less than 50% will be coming in the form of charcoal. However, if we increase the temperature, of the process from 500 Celsius degree, and I show you here, and now we go for 700, you will see that the distribution between the energy gas, the pyrolytic oil, or the charcoal change. For instance, if we go to 700, we have high temperature, we have more energy. So in the paper, we can obtain more, in this case, low energy gas to produce electricity. But in the case of biosolids, you can see that the proportion change when we compare with the previous case of 500 Celsius degree. So finally, I would like to discuss with you some of the mechanism again for producing bioenergy products, and in this case it's called enzymatic microorganism. To be honest, this process is not typically used for high power production. However, it's a technology that is highly evolving, and especially because this kind of technology can be used at the very end for producing biohydrogen. So when we are talking about this enzymatic process, we have the anaerobic digestion, that basically the process produces a biogas. And in this case, we have a condition that there is not oxygen in the liquid biomass, but in this case, with the use of a very specific bacteria, in this case, methane can be used to heat and convert electricity in turbines, because those bacteria will release methane from the biomass, okay? The other process is called esterification, and that is the process that is typically used to obtain biodiesel. In this case, oils are used in mix with an alcohol like methanol or a catalysis, and the chemical reaction of this will produce something that is similar to the traditional diesel that we can obtain from the hydrocarbons, but in this case, because it's coming from organic matter, is called biodiesel. This biodiesel can be used, for instance, in some diesel engines like the classical diesel engines, in order to be used for transportation, in a public transportation or in a private transportation. Finally, probably one of the promising technologies, we have here the fermentation that can be used for bioethanol. And in this case, what we are doing is we are using a chemical reaction where those sugars that they are very short-chained, they are converted into alcohol, and in this case we obtain some very interesting bioliquids that they are called bioethanol. This process of fermentation is similar what you can find in some of the most used I will say distillery process for creating whiskey or vodka or any other alcohol. So this process is very well known, is very well developed in the industry. Most recently, the attention that the hydrogen is taken. So now there are a lot of research in order to create hydrogen from the biomass. And the good news is that there are very specific types of phytoplankton that they can naturally produce hydrogen. So over here, you can see the names. I will not say the names because they are a bit complicated for my pronunciation. However, what you can see over here is that those phytoplankton, they are able to produce directly by some sort of digestion, producing hydrogen. And hydrogen is very useful and can be collected for producing electricity. The issue here is, of course, the scale, because we need to consider this process that is happening in something that is very, very small and is producing very, very small quantities. However, we are interested on increasing the efficiency of this or the volume of energy produced by this technology by increasing the scale, the size of the number of phytoplankton use, so that can create more hydrogen, okay? So over here, I will not discuss this in detail because we are not chemical engineers, but over here, what you can see is that there are several stages. To be honest, there are two stages that we have this chemical reaction. And over this reaction, of course, the use of light is where we are degenerating and we are producing the hydrogen, okay? So over here now in this slide, what I want to talk with all of you is what is the current status about the energy use that is coming from this very interesting source that is called biomass. So over here you can see this is a plot where we are considering the evolution from very early 1800s until 2019, how the primary energy consumption is divided by types. And as you can see over here, from the very beginning of the time, humans has been using traditional biomass to produce energy. It's very clear that there are many countries worldwide that they are still using wood, for instance, to produce heat at the homes. So it's clear that the biomass is still over there, but the most modern and sophisticated way to produce energy from biomass, like the modern biofuels, is still a field that is growing. So what is important is that this plot over here is representing the global direct primary energy consumption. And you must remember that we are talking about tons of oil equivalent. So here you can see from 1980s, we are talking about 7,261 million of tons of equivalent, and that increase over the time, and we are expecting that will increase to 203 million of tons of equivalent oil, okay? So what is important for us is that we are expecting that in the future, especially for 2030 and 2050, biomass will still be a very important part of the total energy mix. And that is in order to help do two important aspects. One important aspect is, of course, try to use energies coming from primary energy resources, environmentally friendly, and biomass is one of them. But the other important part, for instance, from the electricity point of view, is that this biomass is allowing you to control the electricity production in a very good way, so that can help you to cope with the variability of the other technologies. For instance, other technologies like wind power or like the PV system or photovoltaic systems. Well, another important element that we should remember is that the biomass can be obtained from typical bio waste. So that is a very important aspect, because waste is something that in the past was part of the losses in the energy production sector. But now some waste in some other sectors, they can be reused and they can be employed in order to produce electricity. So over here you can see two plots coming from 2015 where the world primary energy supply was around 13,646 NTOE, where 13.4% was basically coming from renewable resources. But what is very important is from this 13.4, around 9.4 is coming from biofuels and waste. So there is a high participation of biofuel and waste into the use of those resources to produce energy worldwide. And if we go into details, these biofuels and waste represent around 70.7% of the total world renewable energy supply that is used in terms of primary energy resources. Of course, in recent time, if we look to more recent advances, the reduction on the prices related to the solar PV systems and the wind power has attracted more attention for the utilities, and in that sense, from the electricity point of view, of course, we still a dominated place for the photovoltaic and wind power, but we are expecting that these biofuels, especially coming from waste, will be a very important part of the generation mix in the future. Here you can see another statistic, and in this statistic you can see that if we look the numbers on the existing renewable capacity in terms of the different energy sources, you can see here that there is a place for the biomass. But if we consider the total world capacity of 4,700 gigawatts, well, you can see over here that around 52 gigawatts worldwide are coming from these kind of biomass energy sources. So you can see that right now this number is evolving, and we are expecting in the future that this kind of biomass power will develop. Of course, depending where you are located, some countries has more, I will say, technology developed for the use of biomass. So there are some countries, for instance, like United States and Germany, that they have a relative high penetration of this biomass, but those numbers can be enhanced in the future, especially considering that there is a possibility of producing hydrogen, and this hydrogen is a very important energy vector that will allow to cope with one of the most important challenges of the energy transition, and in this case is the variability created by the other renewable energy resources, again, like the wind power and the PV systems, okay? So here you can see that the population, worldwide population using biomass is changing depending of the geographical location. Of course, if you look the numbers over here, 2011, and you compare with 2030 forecast, we are expecting that developing countries, they will reduce the use of, we will say the use of biomass. But in this case, we are expecting that developing countries in Asia, they will increase the use of this biomass, in order to cope with the access, two very important issues in developing countries like the without access to the electricity or without access to clean cooking facilities. In the UK, well, I must be honest, in the case in the European Union and the context of the United Kingdom, there are several legal documents that they have been established in order to define the future targets related to renewables. So, for instance, inside the European Union, since 2008, we have 2008 and 2009, we have boundary binding targets defined for the whole total European Union. So reaching 20% of share of renewable by 2020 was one of the targets in 2009. Of course, right now in the modern times, we have more ambitious targets, especially for 2030 and 2050. But what is important is that those targets include the use of biomass as one of the key indicators in order to reduce the CO2 emission. So initially targets from 2010, they include a 5.75% of biofuels inside the generation mix. However, most recent analysis, they include that we are expecting around 10% of the total energy produced inside the European Union to be coming from the classical biomass. Especially there are countries like the Scandinavian countries where CHP, that means combined heat and power, they produce a lot of resources in terms of municipal and also a council or district heating system. So it's quite typical that in Scandinavian countries, municipal solid waste is used to produce electricity together with this very useful heating system, district heating, that allow the Scandinavian countries to survive to the very cold weather during winter. In the case of the UK, there is a legal document from 2012 that was reviewed in 2022 that basically established 4 principles, policies in order to support the use of bioenergy in order to reduce the carbon reductions and helping in the energy transition, at the same time that they are cost-effective solution for reducing the CO2 emission, but maximizing the benefit and minimizing the cost of the electricity. So in this context, there are several targets. For instance, we are expecting a penetration around 12% of the biomass. In other words, 12% of the electricity produced by 2050 supposed to be related to this kind of biomass. Okay. So UK is very committed with this. Of course, the scale will change over the time, depending on the evolution of the technology. And regarding evolution of the technology, there are some opportunities related with that. One of the very interesting thing is, well, the biofuels, they can produce energy for all the occasions. And also, very old traditional larger power stations, they can fire this kind of bioenergy products in order to produce electricity. So that is a very important opportunity that we can use the traditional power plants, but instead of using the coal or oil, we can use some of those biofuels in order to deliver electricity to the power grid. Of course, we need to take into consideration that each one of the different type of bioenergy products, like biogas or charcoal or any other of the products, all of them have different heat quantities, and of course we need to understand how we can use that inside the energy sector. Another very important property is that the biomass can be used together to produce heat and power, and that is very, very attractive for the weather that we are experiencing here in the UK. Nordic countries like Sweden, Finland, Norway, they have a lot of experience of using combined heat and power in order to cope with the very harsh winter. And finally, another very important aspect is that biofuels can allow a smooth transition from the classical petrol cars or using the classical oil-based gas in order to transit to a CO2 reduction, creating or replacing the petrol using bioethanol, like the case in some part of Brazil, or replace the diesel by using biodiesel. However, we need to consider that there are some other barriers when we are talking about biomass. Biomass, of course, is a very interesting option when we have the resources already available. However, if we need to create the resources from scratch, if we need to grow the wood in order to be used for pyrolysis, for instance, so the question is, how can we produce that kind of primary biomass in a very sustainable way? There are many discussions right now about how the biomass can affect also the production of traditional food for the humans. So that is one of the possible issues. Another issue is which technologies are available now or in the future in order to deliver the final biomass products or services, but in a better environmental way. We need to understand that gasification, pyrolysis, they are still producing some small emissions that they are not 100% free of CO2. So in those cases, we need to be careful about if those technologies can be improved to become net zero. Another very interesting question is what will be the effect of increasing the use of biomass into the environmental, social, economic system. If we need to grow wood from scratch, or we need to grow any other kind of biomass from scratch in order to produce the biofuels, so what will be the impact in the other social economic aspect? Similarly, there are other questions like what biomass markets are really available, or what will need to be established? What financial investment are going to be required in order to create a proper biomass industry to the size that we need and carbon-free in order to enable the energy transition? And finally, what are the risks related to investing in the biomass sector? So we need to understand that we have this biomass. Of course, biomass is able to use residues and waste, but also there is a possibility of using some crops or some materials that they are creating from scratch. Here in the UK, there are some power stations that they are located, for instance, in London, that they are able to create energy based on green waste. But there are some other countries, as I mentioned before, especially Scandinavian countries or northern countries like Denmark, that they have already tradition of using biofuels and biomass, like for instance Denmark. And of course, the cost of the electricity coming from this is changing over the time. I will not go inside the cost because from year to year the technologies change and the cost is changing. There are different types of technologies. As you can see over there, there are different types of technologies. However, the most popular are the steam combustion, the use of biodiesel, but we need to keep developing those technologies in order to reach the net zero. One important aspect is that the society understands that this can be a solution, long-term solution for the energy transition. They can help with the variability of other sources of renewable energy resources. But of course, we need to create in the mind of the users that we are not impacting the food production and, of course, the prices. So the idea is that biofuel, biomass is a reality, and of course, there are several examples of these biofuel and biodiversities that they have been changing over the time, like for instance, how the oil plantation have been changing over the time. Palm oil plantation, there are many discussions about the oil coming from those palms. However, this can be used for producing electricity, and one of these hectares or surface that we use to produce palm oil, well, we need to consider how the impact of changing one crop to another crop can affect the biodiversity of the environment. So, yes, there is a lot of discussion. What will be the sustainability of the biomass? There are many papers and also news talking about how we can create a standard for the biomass, how the biomass will affect the sustainability of other energy sectors, and also food and also CO2 production. It's very important that we consider that the biomass can have impact on the fuel sustainability, but at the same time, there are some other considerations like the balance between producing fuel or food or replacement rate of those kind of crops in order to keep producing energy or keep producing food. Another important aspect is the life cycle of the greenhouse gas emission. Because as I said before, even the best case scenario over here, when we are burning this kind of biomass, there are CO2 emission and CO emission that they can go to the atmosphere. So they are not 100% helping to the CO2 reduction. However, they can be a part in the energy transition to reach the goal of the net zero, okay? So here there is an indicator about the life cycle of the greenhouse gases emission. And as you can see over here, on the left-hand side, you can see over here that in this case, the biopower is one of the elements that we can see that there is a negative impact over here related with the grams of CO2 per kilowatt hour. And probably you are wondering why this is negative. Well, because we are using bioresources. And plants, they are very well known that they produce a very good impact on the atmosphere, especially because they are producing O2, oxygen, the oxygen that we are breathing. So if we analyze the total life cycle of this kind of electricity production, of course, the biopower has a very important positive aspect related to the greenhouse emission. On the other hand, and almost just to finish this class today, you can see that there are some environmental issues related with the use of biofuels. Of course, we discussed that there are some potential positive aspects related to the greenhouse gases, but that depends on many factors like the type of feedstock that we are using, the way that the feedstock is produced, and also how the biomass is produced. So also, there are some concerns about the soil quality that is reducing over the time for producing those crops that they can be used to produce electricity. Also, the water quantity that is and quality that is used to create those crops, fertilizers and pesticides. So there are many, many aspects that we are thinking about in order to get a full picture about the impact of the biofuels in the environmental issues. European Union, as you can see over here, they have an indicator, quantitative indicator that is related to very important elements. For instance, in the European partners 15, in the European area of the 15 countries, or 28 or 25, you can see over here some of the interesting issues, related to obtain, for instance, vegetable oil coming from diesel, or wheat ethanol, or sugar coming from ethanol. And those numbers over here, what they are trying to tell you is the percentage of the land that is required in order to deliver the targets for each one of the countries inside the Union. And as you can see over here, that if we are thinking about the use of diesel, that biodiesel is basically one of the most, I will say, agricultural land consumers. But if we are talking about sugars and ethanol, well, if you remember, those processes are basically an enzymatic process that is require less agricultural land to produce similar results. So here, as you can see over here, there are some original proposals from the European Union regarding defining the target from 2020. And in this case, we are talking about 20% of the energy production coming from renewables. This target has been updated, but what is important from here is that inside this 20%, 10% of the fuel should be renewable. So that is including 35% coming from biofuels. And also this is not only for regular transportation, it's not only for ground transportation, it's also including airlines. So in those cases, again, what is important is that we reflect how the community in the transport sector, and we are talking about air, or we are talking about ground transportation, or even sea transportation, they are including now a very important aspect, that is the use of biofuels in order to reduce the CO2 emissions. Some indicators coming from the European Union, they are trying to use a target of 10% of the biofuel in order to reduce a 45% of the greenhouse gas emissions, okay? Well, we are reaching almost the end of this class. As you can see here, I have some takeaways related with conclusions. Biomass is a very wide and broad set of technologies, but all of them, what they are trying to use is a primary energy source coming from organic, and that means that can be plant or animal. And what is important is that it's expected that in the future a biomass market will be developed. However, we need to take in account the possible risk of those markets, because as you must be aware, there is a climate change, there are more rains, there are colder winters and warmer summers. So as you must be aware, at the time that we are evolving with the weather, well, we are also affecting the possibility of producing those bioproducts to produce and save the electricity. So what is important to know is that those technologies can help in the energy transition. Now, if the question is, will be this the final solution? Well, it's my opinion that is one of the possible options that we can use for the energy transition, but the final solution will be a combination. Here there are some links and references that you can go over there, and those references can be used in the learning process, and I hope you can go over there and have a look. So this is the end of this very interesting class today related with biomass and bioenergy. And this is the end of this class in energy technology and society. Thank you very much for watching. And we will have a session in order to have question and answer. And I will be extremely happy to answer your question. Thank you very much for watching. Bye now.